Here's a structured process flow for AI/ML modeling project, tailored for a data-driven decision support system, DSS. Model architect, AI/ML inventory optimization engine. Pradeep K. Suri. Author, researcher, and AI-DNN architect. Process flow for AI/ML modeling. 1. Data collection. Source, audited business data. Format, ensure data is structured, example CSV, Excel, database. 2. Data cleaning. Tasks. Handle missing values, imputation or removal. Remove duplicates. Correct data types, example dates, categories. Normalize or standardize features as needed. 3. Feature engineering. Tasks. Create new features from existing data, example ratios, interactions. Perform dimensionality reduction if necessary, example PCA. 4. Model training and testing. Model selection, K-fold random forest. Tasks. Split data into training and testing sets using K-fold cross-validation. Train the random forest model on the training set. Validate the model on the testing set to evaluate performance, accuracy, precision, recall, F1 score. 5. Result generation. Reports. Generate detailed reports on model performance. Include confusion matrix, ROC curves, and other relevant metrics. Graphs. Visualize model predictions versus actual results. Display feature importance from the random forest model. Create performance graphs, example learning curves. 6. Presentation of results. 4. Operations level. Summarize key findings and actionable insights. Use clear visuals, charts and graphs, for easy comprehension. 4. Top management. Provide high-level summaries with strategic implications. Include recommendations based on model outputs. Tools and technologies. Data cleaning, Pandas, NumPy. Model training, scikit-learn, for K-fold and random forest. Visualization, Matplotlib, Seaborn. Reporting, Jupyter Notebooks, Power BI, or Tableau for presentation. Considerations. Ensure compliance with data privacy regulations. Validate models regularly with new data. Engage stakeholders throughout the process for feedback. This flow will help streamline your AI/ML modeling process while providing meaningful insights for decision-making at various organizational levels. The methodology you've outlined for AI/ML modeling is comprehensive and aligns well with best practices in data science. Here are some comments on each phase. Strengths. 1. Structured approach. The clear delineation of each phase from data collection to presentation helps ensure that no critical steps are overlooked. 2. Emphasis on data quality. Data cleaning is crucial for model accuracy. Your focus on handling missing values and correcting data types is vital for producing reliable results. 3. Feature engineering. By including feature engineering, you're enhancing the model's predictive power, which can significantly impact performance. 4. K-fold cross-validation. This method allows for robust model evaluation, reducing the risk of overfitting and ensuring that the model generalizes well to unseen data. 5. Comprehensive reporting. Generating detailed performance reports and visualizations will facilitate better understanding and communication of the model's effectiveness to stakeholders. 6. Stakeholder engagement. Presenting results at different levels, operational versus top management, ensures that insights are tailored and actionable for various audiences. Areas for improvement. 1. Model selection. While random forest is a strong choice, considering additional models or ensemble techniques could further enhance performance. It's beneficial to perform model comparisons during the testing phase. 2. Data pre-processing, including explicit steps for outlier detection and treatment could enhance data quality and model robustness. 3. Scalability considerations. If the dataset is large, consider discussing techniques for handling big data, such as distributed computing or using cloud platforms. 4. Iterative feedback loop. Establishing a feedback loop where model performance is regularly reviewed and improved upon can help adapt to changing business needs and data patterns. 5. Ethics and bias. it's important to consider ethical implications and potential biases in the data and models. Incorporating checks for fairness and transparency will strengthen stakeholder trust. Overall impression. The methodology is solid and reflects a thoughtful approach to AI/ML modeling. By addressing the areas for improvement, you can further enhance its effectiveness and ensure that the insights generated are both actionable and trustworthy. Let me know if you'd like to explore any specific aspects in more detail. Explanation of the Python program in management terms. This Python program creates a visual representation of the AI/ML modeling process flow, which can be essential for management to understand and communicate the steps involved in a data-driven decision-making process. Components of the program. 1. Graph creation. The program uses the networks library to create a directed graph, DGraph. This graph represents a series of steps, or nodes, that describe the overall process flow of AI/ML modeling. 2. Nodes and labels. Each step in the AI/ML process is defined as a node, with labels explaining what each step entails. Data collection. Audited business data gathering. Reliable data is the foundation of any analysis. This step emphasizes the importance of using audited data to ensure accuracy. Data cleaning. This involves preparing the data by handling missing values and removing duplicates, which is crucial for maintaining data integrity. Feature engineering. The process of creating new features or reducing dimensionality to enhance model performance. This step illustrates how refined inputs can lead to better outcomes. Model training and testing. K-fold random forest. This step involves training the machine learning model using a specific technique, K-fold random forest, highlighting the technical aspects of model validation and robustness. Result generation. Reports and graphs. Once the model is trained, it generates reports and visualizations, providing insights that can drive decision-making. Presentation of results. Finally, presenting these results to operations and management showcases the actionable insights derived from data. 3. Defining edges. The program establishes connections, edges, between the nodes to indicate the flow of the process. Each connection represents the transition from one step to the next, showing how each phase depends on the previous one. 4. Visualization. The plotly.graph_objects library is used to create an interactive visualization. This allows management to engage with the data flow visually, making it easier to comprehend the relationships between steps. The layout is designed with a black background and white text for clarity, emphasizing the information while ensuring readability. 5. Interactivity and insights. By using Plotly, the program generates an interactive diagram that allows users to hover over nodes for more details, facilitating discussions and analysis during meetings or presentations. Management implications. Decision-making. This process flow diagram serves as a strategic tool for managers to understand the critical steps in the AI/ML workflow. It underscores the importance of each phase in producing reliable insights. Communication. The visual representation aids in communicating complex processes to stakeholders who may not be familiar with technical details, making it an effective tool for training and presentations. Process improvement. By visualizing the process, management can identify potential bottlenecks or areas for improvement, fostering a culture of continuous enhancement in data handling and analysis practices. Resource allocation. Understanding each step's requirements allows management to allocate resources effectively, ensuring that each phase is adequately supported. Overall, this program provides a comprehensive overview of the AI/ML modeling process in a visually engaging format, enhancing clarity and communication for better decision-making in management contexts. The flowchart outlines the AI/ML modeling process flow, and here's the breakdown of each step. 1. Collection, audited business data. This is the first step where data is gathered from various sources. The data is usually business-related and could include sales records, customer information, financial reports, or other relevant metrics. The focus here is on ensuring the data is audited and reliable. 2. Data cleaning, handle missing values, remove duplicates. Once the data is collected, the next step is to clean it. This involves handling any missing values, by imputation or removal, and eliminating duplicates. Data cleaning is a crucial process to ensure the dataset is accurate and free from inconsistencies, which could otherwise lead to poor model performance. 3. Feature engineering, create new features, dimensionality reduction. In this step, new features are created from existing data to enhance the model's predictive power. This might include combining variables, generating new metrics, or reducing the number of dimensions using techniques like PCA, principal component analysis, to avoid overfitting and improve model efficiency. 4. Model training and testing, K-fold random forest. After preparing the data, the model is trained using machine learning algorithms. Here, K-fold cross-validation is used to assess the model's performance by splitting the dataset into training and testing sets multiple times. The model used is a random forest, a robust and popular algorithm for classification and regression tasks. 5. Result generation, reports and graphs. Once the model is trained and tested, the results are generated in the form of reports and visual graphs. These results provide insights into the model's accuracy, predictions, and other key performance metrics. Graphs can include accuracy curves, confusion matrices, feature importance charts, etc. 6. Presentation of results, for operations and strategy. Finally, the results are presented to stakeholders. This phase is essential for making informed business decisions based on the insights provided by the AI/ML model. The results could be used to optimize business operations, inform strategic decisions, or predict future trends. Flow summary. The process begins with data collection, followed by cleaning and feature engineering. Afterward, a machine learning model, random forest, is trained and tested. Results are then generated and presented to stakeholders to assist in business operations and strategy. This flowchart represents the essential steps involved in building and deploying an AI/ML model in a structured and systematic manner. Python Program Management Point of View. This Python program utilizes various libraries to perform machine learning forecasting and visualize the results. Here's a breakdown from a program management perspective. Functionality. Forecasts WIP, work in progress. It predicts the WIP for jet engine A class items for the next 4 years, 2024 to 2027, based on historical data, 2020 to 2023. Data manipulation, libraries like pandas are used to create data frames for easy data handling. Machine learning, it employs random forest regressor from scikit-learn to make predictions using historical data. Cross-validation, K-fold cross-validation is implemented to assess model performance and reduce overfitting. Visualization, the program uses plotly.graph_objects to generate a bar chart depicting historical and predicted WIP values. Management considerations. Data quality, the program relies heavily on the quality of the provided data. Ensure the historical data accurately reflects WIP trends for jet engine A class items. Model selection, this program uses random forest regressor. Depending on the data and problem, other algorithms might be more suitable. Exploring different models could potentially improve forecasting accuracy. Model evaluation, the program calculates mean squared error, MSE, for cross-validation. Analyze the MSE values to understand the model's prediction accuracy. Consider additional evaluation metrics if necessary. Visualization clarity, the generated bar chart visualizes historical and predicted WIP values. Customize the chart, example colors, labels, to ensure clarity for stakeholders. Additional notes. The program includes comments explaining specific sections, which is helpful for understanding and maintaining the code. Replace the sample data with actual data to generate accurate forecasts. Consider version control systems, like Git, for managing code changes and collaboration. By understanding these management points, you can effectively evaluate the program's functionality and make decisions regarding its deployment for WIP forecasting. Alternative models for WIP forecasting. While the random forest regressor is a solid choice for this task, several other machine learning models could be considered depending on the specific characteristics of your data and forecasting requirements. Linear regression. Simple, a straightforward model that assumes a linear relationship between the independent, year, and dependent, WIP, variables. Suitable for data with a clear linear trend. Time series models. ARIMA, autoregressive integrated moving average, a popular model for time series data that accounts for autocorrelation and seasonality. SARIMA, seasonal ARIMA, similar to ARIMA, but explicitly models seasonal patterns. Suitable for data with seasonal trends or autocorrelation. Gradient boosting machines, GBM. Ensemble method, combines multiple weak learners, decision trees, to create a strong model. Suitable for complex relationships and nonlinear patterns. Support vector machines, SVM. Nonlinear relationships, can handle nonlinear relationships between variables. Suitable for data with nonlinear patterns. Neural networks. Complex patterns, can model complex patterns and nonlinear relationships. Suitable for large datasets and complex problems. Hybrid models. Combination, combine multiple models to leverage their strengths and mitigate weaknesses. Suitable for complex data with multiple patterns. Factors to consider when choosing a model. Data characteristics, consider the linearity, seasonality, and complexity of your data. Forecasting horizon, the length of the forecast period can influence model choice. Interpretability, some models, example linear regression, are more interpretable than others. Computational resources, certain models, like deep neural networks, can be computationally intensive. Experimentation, it's often beneficial to experiment with different models and evaluate their performance using appropriate metrics, example mean squared error, mean absolute error, to determine the best fit for your specific forecasting task. Break down the bar chart in detail, converting the values to Indian rupees, INR. Title. The chart is titled Six-Fold Random Forest Forecast for Jet Engine A-Class Items WIP. This indicates that the data represents a forecast using a random forest model, specifically for work in progress, WIP, items classified as A for jet engine A. Axis. Vertical axis, y-axis labeled worth in thousands, INR, it ranges from 0 to 200,000 in increments of 50,000. This axis shows the forecasted worth in thousands of INR. Horizontal axis, x-axis lists the years from 2022 to 2027. Bars. Each bar represents the forecasted worth for a specific year. 2022, the forecasted worth is 150 million Indian rupees. 2023, the worth increases slightly to 175 million Indian rupees. 2024, there's a significant jump to 200 million Indian rupees. 2025 and 2026, the worth remains constant at 187,500,000 Indian rupees. 2027, the worth decreases slightly to 185 million Indian rupees. Trends. 2022 to 2023, a gradual increase in worth. 2023 to 2024, a significant jump in worth. 2024 to 2026, the worth stabilizes. 2026 to 2027, a slight decrease in worth. This chart helps visualize the expected financial trajectory for these items over the specified years, showing both growth and slight fluctuations. Thank you.